This is Linked Data Engineering, lecture number 6, Advanced Linked Database Application. In this part of the lecture we want to talk about semantic search. Just take a look at search engines today. So here, for example, Google. We try to look for Jules Verne in that example, and you see, even when you type, you will see some of the answers, and as soon as the named entity Jules Verne is recognized by the search engine, you will get the result here, and you will not only find documents which contain information about Jules Verne, you will also get information about the named entity that has been recognized, and this is already some kind of semantic search. So Google uses, you might know that, something which is called a knowledge graph, and that knowledge graph is nothing else but a semantic graph, a linked data-based graph, not necessarily linked data, but it occurs or it obeys the same principles, and you have named entities in there, and as soon as one in the search string, a named entity, is recognized, then of course you can display information related to exactly that named entity. And of course, if you know that Jules Verne is an author, then of course then also books can be displayed. This is no problem. And then also if information about his birthplace, his birthday and stuff like that will be displayed. So this is possible if a semantic analysis takes place of the search string and in the backend also of the related documents. And of course then, if you're looking for Jules Verne movies, then of course movies will be presented for you. Not only documents where the words Jules Verne movies are really there, but also of course the content that you describe here, Jules Verne movies, then will be displayed in an extra way. Or here you have Jules Verne books. So for movies and books this already works, and I think that sooner or later also other things will occur there, because search engines nowadays understand more and more what's in the data and what the user really wants. And this they do based on something which is called semantic search. But let's go one step back and look at search engines in general and at the information retrieval paradigm. How does a search engine in principle work? So usually you have a huge set of documents. That's the content of the search engine. Usually web search engines gather their content in a process which is called web crawling. They crawl the entire web and gather all the documents together. They pre-process these documents and then they index these documents, which means they put it in a specific form which is in the end an index. And also then in the application itself, you will have lots of queries, and each of these queries then are mapped to the index, and usually with a string similarity approach, there is a match computed between the query and the index, and the result then will be displayed. So this is the basic, trivial, classical information retrieval process, of course in a rather simplified form. Here you have it again. We have a search query and we have a document from a corpus which contains something like keywords. There's a keyword analysis and all the keywords will appear in the index, and then there is of course a match between the search query and the index term, and then in the index of course there is a mapping from the keyword to the underlying document, and the resulting document will be displayed. This is the principle of so-called reverse indexing. Okay, but information retrieval, especially if you're dealing with natural language, is in kind of a dilemma. So there are several problems, and you might have already heard of them, already also in the first lectures that we had in this series. So for example, here I have looked for Jaguar, and the point is of course natural language has a high degree of ambiguity. So with the same string, with the same term, I can reference different entities. On the other hand, also different words or expressions are used for the same concept, so you have synonyms and metaphors, and this makes information retrieval highly complicated and still subject of ongoing research, because you always try to improve the quality of your search result, which is in the end, you try to improve precision and you try to improve recall. So it means you want to pinpoint, you want to find exactly what you mean, and of course with no exception, and you want to find everything which matches this description that you have looked for. So its recall and its precision, what you try to enhance at the same time. But what makes it even more difficult is that not everything is expressed explicitly in natural language information. There is lots of implicit, of hidden information. You might remember that nice little graphics from the beginning of the lecture. What's the meaning of this message? It's not so easy to understand. It has high there is a high dependency to the given context to understand this. So context knowledge is really important, and also your experience in resolving these ambiguities is important to understand the meaning of the underlying message. And then, of course, the meaning is important. The search engine has to grasp the meaning to give you the correct answer to your question and to understand the documents which are in there. Otherwise, it will only be, let's say, an approximation of the expected results. But most times people are also content with that. Okay, so what's semantic search and how can it help? Prerequisite to a semantic search is, of course, that all of your documents are annotated with explicit semantics. So, for example, with semantic entities, we have learned about the process of named entity resolution. So, scan your text, analyze your text, and map all your entities you find in there to a semantic entity of a knowledge base. Then you can employ so-called entity-based information retrieval, which is high-quality information retrieval because it has much less ambiguity if all the documents are semantically annotated, and then in the search process you do not have to consider high ambiguity terms because everything is uniquely determined there. So entity-based information retrieval is also language independent. Because you do not need language identifiers, you are dealing with entities which can have in different languages different names. But in the end, if you have these names available in your naming scheme, in your gazetteer that you are using to analyze the search question and also the semantic analysis of the document, you are then dealing with an entity-based information retrieval, and you do not have to consider specific language dependencies. So you can make use of an underlying knowledge base in which these entities reside. And then, of course, you can make use of similarities, content-based similarities among these entities, which is usually not possible in the traditional information retrieval process. You can also make use of the relationships between these entities and also bring similarities and relationships into the search process to determine which is a better or a less quality search result. So this can be possible with the help of exactly this semantic annotation. In the end, semantic annotations enable also so-called interoperable metadata for content-based description on one side, or on the other side also for structural or technical description of the content. And the purpose of all that is you could do a content-based navigation. So this is an exploration of the entire search space. Or you can also do a search filtering in the term of so-called search facets. Semantic facets help to filter the search result and to understand the search result better and to refine it in a specific way. So these are possibilities that are viable with the help of so-called semantic search. If you compare semantic search versus the traditional keyword-based search, you have the possibility, for example, to improve keyword-based search in the following points, starting with query string refinement. So you can get, for example, suggestions how to refine your query string to enable more precise or more complete search results. You can enable cross-referencing, which complements your search results with additional associated or similar information. You can easily implement a fuzzy search, which enables the determination of nearby results, or results which are somehow only related close by to the content you were looking for, which leads us to a point which is called exploratory search, that enables also the visualization and navigation of the search space. We will later see examples for that. And of course, in semantic search, when everything is labeled with semantic entities, reasoning also enables you to complement your search results with implicitly given information, simply by making things which are implicitly available in the knowledge base also explicitly available, and to consider these in the determination of your search results. So these are benefits that are achieved via semantic search, which can improve the traditional information retrieval process. What I want to show you now is how does entity-based search work. So usually in entity-based search, let's first look at the lower part of this slide. In the lower part you see the index or a document which has been indexed, and there you have the first man of the moon, and this has been annotated with the DBpedia entity Neil Armstrong. And you have also the moon, which has been annotated with the DBpedia entity the moon. And for example, these entity annotations can be achieved with the help of named entity resolution. Then if you are searching for Armstrong on the moon, let's say you as a user you are typing Armstrong on the moon in the query window, then an entity resolution is performed on the query string, which means Armstrong, because it's given in the context moon, might be disambiguated to Neil Armstrong, and moon might be disambiguated to the celestial body moon. And then simple entity matching simply would try to match entities which have been determined in the search query to entities with which your documents are annotated with. So if you do a simple matching, then for example this document, which mentions the first man on the moon and also the moon, will be among the top hits in your result list. This would be simple entity matching. But this of course is not all. You also can take into account similarities. Let's consider another document, which is here the second man on the moon, and the document says legendary astronaut Buzz Aldrin has revealed some captivating pieces of, and so on and so on and so on. So there Buzz Aldrin is labeled in the entity recognition process, and also moon has been labeled or tagged with the entity moon, the celestial body from DBpedia. Now, of course, our search engine could determine that there is a semantic similarity between Neil Armstrong and Buzz Aldrin. And the point is then also this document, which has a nearby hit or a semantic similarity between Neil Armstrong and Buzz Aldrin, will be returned. But of course it will not be necessarily among the top ranked results, it will be lower ranked, but it will be found simply because of that similarity, which means two entities here are usually considered as semantically similar if they share property value pairs or if they share properties with similar values. Then of course Buzz Aldrin and Neil Armstrong share many similar property value pairs. Both of them were on the moon, both of them were members of Apollo 7, both of them, and so on and so on. So this is the reason why these two men or these two entities are considered similar. Entity-based search also enables you similarity-based search matches. And as a third complement to the traditional match results, you may find so-called relationship-based entity matches. Just consider the following document. Again, we have here the second man on the moon. Moon is attached or semantically annotated with the celestial body. Then we have astronaut, which is mapped with DBO astronaut. And we have Apollo 11, which is labeled with Apollo 11. Now our search engine can make the connection between Neil Armstrong and these search terms, that it find out, for example, that Neil Armstrong is of type astronaut and Neil Armstrong was member of the mission Apollo 11, which puts Neil Armstrong in a close-by relation to this document, which means if I have the search query Armstrong on the moon and I'm looking for Neil Armstrong and the moon, I have first hit direct entity match with moon, and for the second one I have a relationship-based match with Neil Armstrong, which again tells me this document might be an interesting complement for my search result. It does not hit directly, but it is rather closely related, and therefore I will display it also. So you see, recall or completeness of your search result might be enhanced based on so-called entity-based search. But to enable this, your documents must be semantically analyzed or semantically annotated. And therefore, for the rest of this part of the lecture, I will show you a tool with which you can semantically annotate your documents. And this tool is called Refer. You have a link here where you can get to this tool. And this is a WordPress plugin. You know WordPress, this is a content management system for blogs. And we have implemented a small plugin which does this named entity resolution, either automated or manually. And I will show you that on the example of a blog. This is the Jovisto blog on history of science, or history in science, technology and art. And we have here the example of Jules Verne, and the article is entitled in Around the World in 80 Days. So this is a usual blog, a common blog, but we are using a plugin, and this plugin is called refer.cx. The nice interesting thing is you see here several of the words, they are underlined, like for example here Jules Verne, which means Jules Verne is annotated with a semantic entity in DBpedia, which enables us to make a direct link to Wikipedia and to gather additional information about that entity and to display it here directly in the blog. So if the user really wants to know more about Jules Verne, you can look here, for example, you hover with the mouse over it, and then this is directly loaded from Wikipedia, additional information about Jules Verne. You can also choose something else. So this is in Around the World in 80 Days. So you will see here information about the book. Or let's look another one, Phileas Fogg. So this is a fictional character, the main character of Around the World in 80 Days. And if you hover over it, you see Phileas Fogg is the fictional main protagonist of the 1873 Jules Verne novel Around the World in 80 Days, and stuff like that. So this can be loaded on the spot, on the flight, dynamically. So this means if this information changes, you have the semantic annotation, you can look it up in the knowledge base in Wikipedia and then directly display this information. So this would be an enhancement of the presentation of this article, which is caused by semantic annotation. But let's have a look how this annotation really works. So you go in the edit mode of this WordPress instance, and you see here, so this is the typical window of WordPress, and you see here the article, and you see here things which are annotated, and you see these here, they are surrounded, there are these little boxes around these terms, and if I click on it, you see over there, this is the annotation, this is the URI of the DBpedia entity Jules Verne, for example. So this is already annotated. If I want to annotate something else, so for example here, if I want to annotate Phileas Fogg, I simply highlight it, and then you see there's something, there pops something up, and this is an interesting disambiguation and annotation interface. So here you have, for example, persons, places, events, and other things. You see here, this is red and this is blue, so they are highlighted. So Phileas Fogg can mean something else or a person. So we say, yeah, it's a person. So I click on person, and you see here, there is a fictional character, Phileas Fogg, and you have also a depiction of that. And if you think, yeah, that's correct, then you simply click on it, and there you have the annotation. Or try the same one here with Savile Row, which is a road in London. And you see here already the place is highlighted. So it means it has detected that this is a place. I click on the place, and I get here, I have here Savile Row, London. In infrastructure, I have also another possibility as an architectural structure. Seems to be exactly the same thing, so therefore I take here the Savile Row. So I have annotated this here with Savile Row. This is quite easy. You can also, for example, take London. I click on it. Whoops, sorry. Again, I click on London. London can have many different meanings. So, for example, can refer to lots of different events, as you see here, and you can select from it. It can also refer to fictional character with the name of London Tipton or Louis London. Interesting. But of course, it can also refer to a specific place or town or infrastructure, London Bridge, and so on. So we go for the place and say, yeah, this is London, definitely. So that's it. That's the annotation. I can update it. And then if I go to the article again, I click on it. And you see here London, for example, that's the annotation I just made, and you see here information about London, which comes directly from Wikipedia and DBpedia. Interestingly now, if you want to have even more information about Jules Verne, simply click on it, then a new window pops up, which gives you a new interface, and in this interface you will see another information visualization. And so you see here our main entity, which I clicked on. It was Jules Verne, and you see here 4 rows. The first one stands for person, the second one for places, the third one for other things, and the fourth one stands for years or events and stuff like that. So if I want to know what's the relationship among Phileas Fogg and Jules Verne, I simply hover over it and you see Phileas Fogg. The creator of Phileas Fogg was Jules Verne. That's interesting. Or go to that one. Pierre Jules Herzl, that's the publisher of Jules Verne, or it's the publisher of the books of Jules Verne. You see here, Pierre Jules Herzl is the publisher of, let's say, Master of the World, which is a novel which is authored by Jules Verne. So you see, interesting facts can be displayed in this kind of interface. Sandokan, oh, what's interesting. It's also a fictional character. Let's see what's the... Sandokan is a fictional character by Emilio Salgari. It's an Italian writer. And Italian writer Emilio Salgari, or Salgari, was influenced by Jules Verne. So that's an interesting connection, which is not necessarily information which is available directly in the blog article, but which comes from the knowledge base and which is visualized here. So this interface enables you and gives you an exploration interface for the data which is in the knowledge base and which is related here with the entity which has been annotated in the blog. So you can see these pages of these interfaces also here in the presentation. But going back to this information exploration interface, this gives way to exploratory search, which means if we want now to find out what is in the search space available and how can I find possible ways through the search space and navigate from information to information, I come to a process which is usually referred to as exploratory search and which is rather close to so-called recommender systems. And this will be subject of the last part of this lecture.